As I promised from last week that today it is not a day that you need to attend the class. It's we already have our spring break, but I would like to use this time to go over my old test too, so that you can have something to study during the break. Now, before that, I would like to share with you that on our discussion board, I already shared, I went over the test two with my West LA College class. So if you go to our discussion board for today, you will see the recording that I did with my West LA College class on Wednesday. And that one, I went over, I believe I went over fall 20 and spring 20. Yeah, fall 20 test 2 and then spring 20 test 2. That's what I went over with them. So with you today, I will go over different ones. I will go over the one from spring 19, and I think the other one will be fall or spring 17. I don't remember. Okay, let me just start. Number one, Real Clear Politics poll conducted between March the 25th and April the 6th, 2019 result in 38.3% of those surveyed said the country is going in the right direction. So the portion that it is right direction, that's 38.3%. The wrong track, that's 53.3%. And undecided, unknown. But let's find out what percent is that. The total should be 100%, right? So 100% minus 38.3 minus 53.3%. What's that? That's 8.4%. Okay, so you use 100% minus those two numbers. 100 minus 38.3 minus 53.3. Okay, that's 8.4%. Now then, let's start part A. Of 50 people, find the expected number of people who say the country is on the wrong track. So suppose you are given 50 people. What is the probability that it is on, what is the expected number of people say that it is on the wrong track? So the proportion is 53.3%. So the expected value will be, let me call that X sub A, is 50 times 0.533. The formula is n times p. Expected value is n times p if x is binomially distributed. Okay? 50 times 0.533 is 26.65. Don't forget that you need to write your notation properly though. You can also use mu if you like. Okay, you can also use mu if you like. Now, part B, of 60 people, find the standard deviation of number of people undecided. 60 people, the proportion that is undecided is 0.084. So the variance is NPQ. Maybe I write it the formula here. The variance is NPQ. Okay, so the N is 60. The P is 0.084. The Q is 1 minus that 0.916. So 60 times 0.084 times 0.916 give me 4.61664. So the standard deviation will be the square root of that. That is square root of 4.61664 equals to 2.14864. Part C. Find the probability that of 9 people, more than half say the country is going in a direct direction. So the number of people, 9, probability or the proportion that they say it is in the right direction is 38.3%. Okay, now then what is the probability? Now we know the portion of people saying that the country is going to the right direction is less than 50%, right? But if you randomly select 9 people, what is the probability that more than half of them say that it is going in the right direction? Now more than half means more than 4.5, right? Okay, the complement will be 1 minus the probability that number of people say that it is going to the right direction is at most 4. More than 4.5 means start from 5. Yeah, more than 4.5 means start from 5, right? 5, 6, 7, 8, 9. Maybe I write it down here. So 0, 1, 2, 3, 4, 5, 6, up to 9, right? Now, when we say more than half, that refers to 5 and on. Now, the complement of that is up to 4. Okay? The complement of that is up to 4. Then we compute the probability. That's 1 minus. Now, every time you need to use the distribution from our calculator, you need to write the calculator notation first. Okay, binom CDF 9 0.3834. That is 0.76792, and then you subtract from 1, I get 0.23208. That's the probability that even though we know the proportion is only 38.3, but if you randomly select 9 people, there's still a possibility that more than half of them, I'm sorry, more than half of them say that the country goes in the right direction. Part D. Find the probability that any of 10 people undecided. We are having 10 people. The proportion that has undecided is 0.084. Now, probability that any undecided, at least one, right? That's equals to 1 minus probability that the number of people undecided is equal to 0. That's 1 minus binom PDF 10 0.0840. And I use my calculator, binom PDF 10 0.0840. That's 0.41587. So that's 0.58413. Okay, so even though the proportion of people who cannot really tell or they don't decide uh, that the country going to right direction or not, only 8.4%, but of 10 people, there could be at least one person have that mindset. Okay. And in fact, the probability is 58% something that you have at least one person of 10 randomly selected people say that they can't really tell if the country going to the right direction. Okay. To give you some background, that at that time, when this poll was conducted, this is 2009. Okay. So at that time, the president was still Mr. Trump, yet the Senate yet the Congress is held by Democratic Party. Okay, the majority is Democratic Party, who has the power of purse. So at that time, I tried to ask myself, and therefore I went to real politics to see if the way the money being used by our government at the time going to the right direction. And this is one of the indicator I look at. Okay, now I'm not trying to influence you in any way. Okay, and I'm not trying to uh, how to say that, make you think the way I think that you have to think. You need to have the same opinion with me. I just show you that the president has the power to use the money, but the money that he get actually coming from Congress. Okay, so to blame it on one party or one president may not be right. I prefer to say that. Actually both of them are not working well together. You know. Okay, whose fault is that? I'm not pointing my fingers. What I know is like the country is not going to the right direction, and more than 50% of the population actually say so. Okay. Now, you may get 10 randomly selected people, and at least one of them still say, no, I don't know. It doesn't matter for me. Okay, so there is no contradiction. What I'm trying to say is there's no contradiction of saying that the number of people undecided is only 8%, and among 10 people you have more than 50% chance any one of them say that way. So it's not something hard to find. It's not something hard to find somebody among 10 people who say that they don't really think the country going to wrong or right direction. Okay, that's not unusual. In fact, it's more than 50% chance. Okay, and it doesn't mean this country is divided either. Oh. The fact that a lot of people at that time say that this country is very divided, it turns out that it's actually not that sharp. Yeah, the country is divided. Find me another country that is not divided, right? Okay, unless that country is so authoritative, it's led by a dictator. But no. I want to say that regardless what is your political view, I have my own view, and America is still a country that I'm so happy to be in. Okay, I mean, I can't expect a country that is so perfect. You know, you want a perfect country? Get out from that country, then that country becomes perfect. My point is, like, if you this illustration actually coming from church. My pastor usually say that you want to get a perfect church, get out from that church, then it becomes perfect. Yeah, there's no perfect place. Yeah, Now, part E of 60 people, so n equals to 60 again. Find the usual interval for number of people undecided. So the P is 0.084. To find the usual interval, I need to find the expected value. That's n times P. That's 60 times 0.084. That's 5.04. And the variance is n times P times Q. Why I feel like I did this problem earlier. That's 4.61664. Oh, that's part B. So the standard deviation, no, it should be E, not D. Is the square root of that. That is 2.14864. So then the lower fence will be the mean minus twice the standard deviation. The upper fence is 5 point, the mean plus twice standard deviation. .04 minus 2 times 2.14864. That is 0.7 something. And the upper fence give us 9 point something. So the usual interval will be 0.74272 up to 9 point something. Oh, okay. So among 60 people, it is rather unusual to have nobody undecided. You see? Right? Okay. Among 60 people, zero number of undecided is actually rather unusual. Okay. It should be more than 0.7, means it starts from 1. You expect to have at least one person among these 60 people that are undecided. Okay, question number 2. Super Lotto plus lottery draws 5 regular number from 1 to 47. So 5 of them correct, 42 of them wrong. And 1 Super Bowl number from 27. So 1 of them correct, 26 of them wrong. Now part A, find the probability to correctly select Super Bowl number only. So only this one is correctly selected. Means nothing from here. Okay, means the regular numbers, 5 regular numbers that you select are all wrong, right? 5 regular number that I select are all wrong. Means nothing correct one selected. So what is the probability? There will be 5 choose 0 times 42 choose 5 over 47 choose 5 times 1 choose 1 times 26 choose 0 over 27 choose 0. And here I say just use the notation, do not compute into decimal. Now, if you want to, you can. Okay, if you want to, you can. You just don't have to. Okay, you can just leave it like that. Okay, but Just for fun. Do you know how to compute that? Just for fun. 5 choose 0 is 1. 42 choose 5 is 850668 over 47 choose 5 is 1533939 times, I'm sorry, this is 27 choose 1, not choose 0. This is choose 1. So this is 1 choose 1 is 1, 26 choose 0 is 1, 27 choose 1 is 27. Okay, now then 850668 divided by that 1,000,000 something times 27 give us 0.02054. That's if you need to compute the probability. Okay. Yeah, but I will check your ability to compute combinations in other place. That's why I say just use the notation. All I want to know here is, do you know the technique? Okay, and apply that into our notation. Part B, find the probability to correctly select 3 regular numbers only. So of 47 regular numbers, okay, 5 of them correct, you need to select 3. And the other 2 therefore has to be the wrong one, right? You still need to select 5 regular numbers. Now, what is the probability that 3 of them correct? Okay, and for the Super Bowl of 27, okay, there are 1 correct one and 26 wrong one. You just need the correctly 3 regular numbers means the Super Bowl is incorrectly selected. Therefore, the probability will be 5 choose 3 times 42 choose 2 over 47 choose 5 times 1 choose 0 times 26 choose 1 over 27 choose 1. Okay. The 5 choose 3, 42 choose 1. 42 choose to 5 choose 3. 42 choose 2. 1 choose 0. 26 choose 1. Okay. 47 choose 5. 27 choose 1. Okay. That's for this number 2. By the way, I almost always have this question number 2 in number 2, if you pay attention. And I don't plan to actually change that. Well, what is my purpose? My purpose is this. Even if you do my test only by memorization, and especially I let you have your cheat sheet, right? I let you have your notes. Then if you are prepared and you just memorize, you should be able to get at least that 60 point. Okay, 60 points, 70 points should be within reach. Okay, but you still need to study though. Now, if you don't study and you try to do my test, of course, then you will end up studying during the test and you will end up not having enough time because you try to do 2 things, doing the test and study at the same time. Now, of course, it's not doable. Okay, it's not doable in 2 hours. Okay, Thomas, why don't you just give extra time? Well, you're supposed to study before the test, not during the test. So no, you are the one supposed to give yourself extra time to study instead of asking me giving you extra time, right? Okay. No, I'm not trying to be sarcastic. I'm telling you now what you need to do. Okay. I'm telling you now what you need to do. Telling you that you're supposed to study before the test and tell you that after the test, after the fact, it will not solve the problem. Okay. That sounds more like teasing. Now, I'm telling you this before the test. By the way, I want to say that I'm very happy with your test 1 from East LA College. The result is actually very encouraging. I'm basically very happy with the result because I have one person get perfect score. I have one person get perfect score, somebody get 108, and two other people get more than 100. So 100.5 and 101. So there are three people get more than 100. Okay, as I remember, there were some people get 90s. Okay, but I also have somebody get 6 points only. So I don't really know how to explain how somebody, like, in case that person asks me, Thomas, your test is so hard, why I get only 6? Then I will show you the other side. You know, I have three people get uh, more than 100 points. Okay, so if you ask me to explain how can somebody do very bad in my class, I would like you to explain to me first, how can three people doing so well in this class, in the test at least? Okay, I don't know. I don't know. Oh, maybe they're cheating. Well, how about the person who gets 6? Maybe he or she didn't study. Okay. Basically, with this kind of extreme statistic here, right? You cannot blame it on me anymore. It's on your own. Okay. That's why I want to say that those people who get this 108, 100.5, and 101, you did a very good job. Okay. You did a very good job. Okay. Because other students taking these tests, somebody gets 6. I have some people get less than 20. You know, and really, I don't know. I don't know how could that be? How could that be? Okay. The only possible explanation is if you don't study. Okay. My daughter is not really. I need to tame my daughter first. Give me some time. Okay. Now let's continue. Number 3. The following lists the probability distribution of X, the number of people in a compact car going into a parking structure. Extend to find the mean and standard deviation of the number of this is a clearly copy paste, the number of people in a compact car into a parking structure. Okay, the total is supposed to be 1. Give me a second. The total has to be 1. Okay, and then 1 minus 0 0.6 minus 0 0.3 minus 0 0.02. So it should be 0 0.08. Okay. So to find the mean, I need to do the first extension. This is 0, 0 0.3, 0 0.16, 0 0.06, 0 0.52. So the expected number of people in a compact car into a parking structure is 0.52. I think I should say passenger instead of number of people. Yeah, to be more precise, it's supposed to be passenger. It will be quite scary if it's quite scary if a car going to a parking structure without anybody in there, right? Okay, so this 0 here refers to the number of passengers instead of nobody in that car. Now then, to find the variance, I need to do the second extension. So x squared and then px squared. 0.149 multiplied by the probability So when I add this, I get 0.8. Oh, nice number. So the variance of x is 0.8 minus 0.52 squared. That's 0.5296. Therefore, the standard deviation is the square root of that. 0.72774. Okay. Oh, by the way, please don't do this. Don't do this. Some people were so lazy. I don't know what happened. Some people were so lazy. They just write it this way. Oh, this is the expected value. Like that. No. That's the table part from the table. Okay. Now, and then you write the expectation separate from there. I know what you mean though. Okay, I know what you mean. But that's not the right way to say it. Okay. Write it separately. As if that's your conclusion from the table, instead of just say from the table. Number 4. A box contains 9 identical marbles, except in color. We have 4 green, 3 yellow, and 2 red. Now 3 marbles are selected at random, one at a time, without replacement. Okay, without replacement. Find the probability of selecting any red marbles. Probability of selecting at least one red marble. That is 1 minus probability of selecting no red. Okay, which is 1 minus. How many red, by the way? There are 2 red. Means 7 not red. Okay, if we want to select no red, means 3 times back to back, we will select non-red. So 7 over 9 times 6 over 8 times 5 over 7. Now, by the way, that's one way to do that. The second way to do that is you use hypergeometric distribution. Okay, nothing from here, 3 from here. So 2 choose 0 times 7 choose 3 over 9 choose 3. Now both of them will give you the same result. That's 1 minus, let me see, 7 times 5, 7 times 6 times 5 divided by the product of 9 times 8 times 7. That's 0.41667. So that is 0.58333. The probability we get at least one red when we randomly select 3 marbles from here is 58%, 58.3 something percent. Okay, now, by the way, it is not all the time you can do it this way. It just happened that if you have no red, means all of the are not red, right? Okay, now we can use hypergeometric method, or you can just do it one by one. That's for part A of this number 4. Part B, 4 marbles are now randomly selected, one at a time, again without replacement. Now, what is the probability that you get 2 yellow first and then 2 red? Let's see the setup. So there are 4 green, 3 yellow, and then 2 red. Now, what is the probability to get yellow and then red and then red? The probability to get, oh, by the way, this is without replacement, which means after you get the ball or get the marbles, you don't put it back. Now, the probability, the first one is yellow, is 3 out of 9. Now, what is the probability to get a yellow again? There are only 2 yellow out of 8 marbles, times, what is the probability to get a red after that? That's 2 out of 7 marbles left, times 1 over 6 marbles left. And this will be, you know what, let me do canceling. So 3 times 2 is 6, can cancel with that 6. So 2 cancel with that 8 becomes 4. So 36 times 7 is 252. So that is 1 over 252. That's if you want to leave it in fraction. But also feel free to leave it in decimal. That's fine. That's 0.00397. Okay, that's for part B. Part C. 4 marbles are randomly selected, this time with replacement. Now, what is the difference then, Thomas, if now with replacement? Means probability for you to get, in this case, a green, probability of you to get a green marbles in the first choice, and probability of a green marbles in the second choice will be the same. Why? Because we have 4 green and 5 not green when you make your first choice. Okay, and regardless what you get in the first choice or in the first selection, when you are about to do your second selection, you get exactly the same configuration. So the probability to get green is constant throughout the experiment. Okay, now then find the probability of getting 2 green marbles regardless the order. Now this fits binomial distribution. Okay, so let X be number of green marbles selected. This X will be binomially distributed with 4 trials. The probability of each success will be 4 out of 9. Now, this 4 here comes from 4 marbles selected. So if I change that 4 marbles becomes 5 marbles selected at random, then you change that n becomes 5. However, the probability of getting a green is 4 out of 9. Probability of getting a green is 4 out of 9. Now, the question is, find the probability that the number of green, or actually X in this case, is equal to exactly 2. Then it will be binom PDF 4 over 9, 2. Okay, the number of trials is 4. Probability of success in each trial is 4 over 9. And you don't need to make it decimal. You just type in 4 divided by 9 for the P. And the number of successes is 2. I get 0.3657780. That's the number of the probability of getting 2 greens with replacement regardless the order. Let me go on. Part D, create a probability distribution of the number of yellow marbles selected for a procedure of selecting 4 marbles without replacement. So let Y be number of yellow marbles. So the Y have 3 possible outcomes, actually 4, either nothing, no yellow selected, or 1 yellow selected, or 2 yellow selected, up to 3. Now, notice that even though you select 4 marbles, right, you have only 3 yellow available. You cannot have 4 yellow selected because this is done without replacement. If it is done with replacement, then you can have 4 trials and you get all 4 yellow because you always put it back, right? Okay, now in this case, because it is without replacement, then you can have at most 3 yellow. Now, we need to compute the probability for each one of them before we put those numbers into probability distribution. So let's compute. What is the probability? Let me do it here. What is the probability that the number of yellow marbles selected is 0? So you look at your box. We have 3 yellow there and 6 not yellow. If none of the yellow selected, you select 4 marbles, right? So if none of the yellow selected, then the 4 that you select must be not yellow. Okay, so that will be 3 choose 0 times 6 choose 4 over 9 choose 4. 1 times 15 over, what is 9 choose 4? 126. So this is 15 over 126. Now, how about the probability of selecting 1 yellow? Let me do it here. Probability that yellow equals to 1. So 1 yellow means the other 3 that you selected cannot be yellow. Again, because you select 4 marbles. You still select 4 marbles. If one of them yellow, then the other 3 not yellow. That's 3 choose 1 times 6 choose 3 over 9 choose 4. That's 3 times, what is 6 choose 3? 20 over 126. That's 60 over 126. Now, how about the probability of getting 2 yellow? Let me partition that here. To have 2 yellow out of 4 selected means the other 2 are not yellow. That's 3 choose 2 times 6 choose 2 over 9 choose 4. That is equals to 3 times 6 choose 2, that's 15, over 126. That is 45 over 126. And finally, probability that we get 3 yellow, all of them yellow. Oh no, I cannot say all of them yellow. We have only 3 yellow to select with 4 different chances, right? So at most 3 yellow selected. Okay, at most 3 yellow selected. So 3 yellow selected, then one of them cannot be yellow. Basically, if you have only 3 yellow marbles and you need to select 4 without replacement, then consequently, at least one of them not yellow. At least one of them not yellow. Right? Does it make sense? Okay, so that's 9 choose 4. This is 1 times 6 over 126. That is 6 over 126. But we are not done yet. The question is to construct a probability distribution. So you need to summarize it with a distribution, X and P. Okay, probability, I'm sorry, I used Y earlier, not X. y and p. Okay, the probability that y equals to 0 is 15 over 126. And please don't write your fraction this way. I think I said that before. Don't write your fraction this way, especially if your vertical line is near your slant nearly vertical. That's not right. A fraction should not be written like this. No, this is a wrong way to write it. Even like this is actually not correct. Do you know that? It's supposed to be smaller number and then slash and then smaller number, not the same size. But Thomas, I saw a lot of people doing that. Well, that's because in the past, they used typewriter to type it. They use typewriter to type it. So the size are the same with the regular size, but still, they still type it this way, regular size slash regular size, but the 15 is typed a bit higher and 126 is typed a bit lower. Okay, so don't tell me that, Thomas, that's what I saw, but you don't care about how what a typewriter at that time. You need to live long enough to know what is a typewriter. I know, but I used typewriter before so that I can tell you. My typewriting teacher, I learned to typewrite also before. My typewriting teacher will mark it wrong if I type my fraction this way. No. Okay, I think one day I will go find a typewriter and keep it at home, at least as an antique, and then I can show you how typewriting was the typewriter type certain things. And it's not a justification of you typing it that way or writing it that way, as if you don't have that flexibility. Okay, typewriter typewriter doesn't have that flexibility like we are right now. I mean, you do handwriting, right? So it is a lot easier to just write whatever you want. Now, if you have that, then you need to write that the way it's supposed to be. Okay, and no, it's not because Thomas says so that it has to be like that. That's how it is supposed to be. Okay, I myself just tell you what it is, how it is supposed to be done. Okay, and then right now 3 is 6 over 126. The key is when you add them, it's supposed to show 1. Then it is confirmed it is a probability distribution. Okay, now that's for the end of page 2. Let's go on. Now, you always see this type of question in my test. I think so far, all question number 1, 2, 3, 4 are questions that you see a lot. Number 5 are also common questions. The only new question in this test, I believe, is at that time, the new one was the Poisson distribution. The first time I asked Poisson distribution in my test was in spring 19, so 2 years ago. Yeah, that's the first time I asked Poisson distribution. And this is a test at West LA College. At East LA College at that time, I didn't give Poisson distribution yet. That's why if you compare, if you happen to have access to my Spring 19 Math 227 East LA College, then you will not see this Poisson distribution for number 8. I replaced that for some other question. Okay, let's go back. For your test, expect something look like this, very, very similar. Page 3. Probability of A 0.5, probability of B is 0.3, probability of A given B is 0.4. But probability of A given B is probability of D intersection over probability of B, not over probability of A. Now, if I need to find out probability of the intersection, then I need to use this, which is 0.4, and this, which is 0.3. Okay, now let me write the formula first down here. So probability of A given B is equal to probability of D intersection over probability of B. Now we plug in numbers. 0.4 equals to probability of D intersection over 0.3. Now then probability of D intersection therefore is 0.4 times 0.3. That is 0.12. Now, how about probability of B given A? Probability of B given A is probability of D intersection, which we just found from part A, over probability of A. That is 0.12 over 0.5. That is 0.24. Okay. Now, how about probability of the union? That's probability of A plus probability of B minus probability of D intersection. That is 0.5 plus 0.3 minus 0.12. What's that? 0.68? How about probability of not A but B? That's probability of the whole B first, and then you subtract probability of the intersection. That's how you kick the A away. That is 0.3 minus 0.12. That is 0.18. Therefore, what is the probability of B knowing it is not in A? That's probability of not A but B over probability of not A. That is 0.18 over 1 minus probability of A, which is 0.5, right? Yeah. 1 minus 0.5 is still 0.5. That's 0.36. Okay, let's go on. Number 6. This is the heavy one. This is the heavy one. A game of twin tins draws 2 cans of soda without replacement from a box containing 9 identical cans. That's 4 Sprite, 3 Coke, 2 Fanta. Oh, I have this question very often, huh? Okay, now the player wins $10 if all cans selected are Sprite, 50 if all Coke. Maybe I mark it this way, 10 if all Sprite, $50 if all Coke, and $100 if all Fanta. Now, it doesn't say what happened if you get other situation. Okay, so if you have this kind of game in your party, play. If you have this kind of game in your party, play. Why? You have no chance to lose. You have only chance to win. Right? Okay, that's only chance to win. By the way, now, but Thomas, do you think this is possible that somebody actually played like this? Yes, actually quite common. Actually quite common. Let me tell you, this is actually a type of, not exactly like this though, but a game in which you don't have any chance to lose is actually quite common in the countries where bribery happens a lot. Okay, so for example, suppose, so I'm not teaching you moral, okay? I'm not saying that this is right. I'm just saying that, or wrong. I'm just saying that this is how you try to bribe somebody without actually bribing them. Okay? Put them in a game where they have no chance or very small chance to lose, and the expected value is very high. Like in this case, the expected value is positive. In fact, there's no chance for you to lose. So suppose Thomas wants to bribe Tim. Okay, suppose Thomas wants to bribe Tim, and I want to give him, let's say, $10,000. Okay, I want to give him $10,000. But the thing is, to show that the money being transferred to him, not just like getting $10,000 in his account, but legally obtained way, then Thomas create a game, some kind of gambling. Okay, some kind of gambling where, for example, well, if you get two Sprite, you get $10. If you get two Coke, you get $50. If you get two Fanta, you get $100. Okay, and if you get anything else, you don't get any money, but you don't lose money either. So, Tim, will you play this game where there's no chance to lose? Tim will say, of course. I play it. Okay, just play it many, many times until you already make $10,000. Then we stop, right? And then for that to happen, to make sure that it is not an illegally obtained money, then Tim will record that, will video that, put it on YouTube maybe. See, I get this money. I get this money legally. I went to the party, and the host offered me to play a game in which I can only win. Okay. Now, of course, under American law, that could be still considered bribery, but at least we try to conceal that under the big name of gambling or a game. Okay. Now, this is done in countries where bribery is rampant. Yet, the corruption eradication is being started. So they need to come up with an evidence. Tim needs to come up with an evidence that he got the money not from bribery, but from playing a game, from playing games. Now, Tom may need to invite other people beside Tim, just to conceal as if the money is purposely given to Tim only. Okay, so let's say there's Tim, there's Tom, there's Tom's, there are Tam, and there are whoever there and play the games. And Tom needs to be willing to give out more money than just $10,000 that he tried to bribe Tim with. Okay, so please don't think that bribery can be done only by like I send money to your account, I give you cash. No, other way. This is another way to do it. Okay, in Indonesia, for example, there's a law says that that let's say you are government staff, right? And if I want to give you some appreciation, let's say you help me with some project to give me the permit, and everything was done properly. It's not that I try to bribe you, but I'm just really thankful that you are willing to help me. So I can give you, let's say, some parcel, as long as it is less than, I think, $10, maybe. I make up numbers, okay? Maybe less than $20, then it is okay. So I give you some gift. As long as that gift is under certain threshold, then I don't need to report that to the government. Okay, so let's say Tom is the staff, government official, okay, and somebody give some parcel or basically some package as a gift to Thomas as a token of appreciation, then I don't need to report that. Okay, let's say some chocolate, right? What do you think about 5 chocolates? Do you consider that bribery? Or maybe 1 Toblerone? Do you think that's bribery? I don't think so, right? Now, the thing is, when that Toblerone was sent to me, when that Toblerone was sent to me, they packed that in a box made of gold. And I keep the box. So you tell me, is it bribery or not? It is bribery. But when I give you that Toblerone, because it is less than $20, I don't need to report that, right? I mean, you, the one who received that as a government official, you don't need to report that because what? It's less than $20. Okay. Now, nobody will report what kind of box that Toblerone sent to you with. So the Toblerone itself cost from Ralph is only $1.5, but the box made of gold may cost $10,000. Of course, this is clearly bribery, but that's also how those people get away from reporting this. You see how evil? If, in other words, if people try to be want to be evil, they can be evil. Okay, they will come up with all method to do nasty stuff. Okay, it is embedded in our nature. You know, it's just about, are you willing to avoid doing it? Okay, now let's start coming back to here. Okay, so let's start with defining a payout. Okay, because the question is construct probability distribution of the payout. Then the payout should be the random variable, right? Let X be the payout. Now this X may be $10, $50, or $100. Really nice game. You can only win. Okay. If you have this kind of game in your party, trust me, your party will be so fun for whoever come. You can call that gambling because the probable you have random variable there. What you get is not necessarily 10, 50, or 100. Maybe you don't win anything. Okay, but on the other hand, you cannot call that gambling because you have no chance to lose. Right? Yeah. Anyway, I'm smiling because I'm telling you that this is how some people actually doing it. Like when I need to bribe somebody, but I need to conceal that. What can I do? Well, ask that person to you come to my house. We have a game. We play cards. Okay, we play cards. Okay, and then during that time, I will purposely make myself lost. That's how I give the money to you. Okay, that's why government official in some other countries, as far as I know, in China, for example, are prevented from playing any type of games. Okay, because they may get invited to certain party, and in that party they have games in which there's no chance to lose. That's how the bribery is done. Okay, now unfortunately in other countries, for example Indonesia, that idea is not being developed yet. Like the government official can go to invited to a party where they have games that you can only win, and that's how the bribery is actually done. Okay. You don't know. I don't know about America, but I suspect that also being done in America. Okay, but I don't have evidence. I don't have evidence. Okay, let's see. Then what are the probability? What's the probability for each? Probability that you win $10 is equal to probability to get 2 Sprite, right? You only select 2, by the way. Now there are 4 Sprite and 5 not Sprite. You select 2, and 2 of them from the Sprite means nothing is selected from not Sprite. Then the probability will be 4 choose 2 times 5 choose 0 over 9 choose 2. That's 6 times 1 over 36. How about the probability of getting 50? Probability of getting $50 is when both cans that you select are Coke. Both cans that you select are Coke. Maybe I leave it there. Okay, so you have 3 Cokes, which means the other 6 are not Coke. You need to select 2 from here, nothing from here. That will be 3 choose 2 times 6 choose 0 over 9 choose 2. 3 choose 2 is 3. This is 1 over 36. That's 3 over 36. That's the probability. Now, how about the probability that you get $100 instead? There are only 2 Fanta, and you select those 2. Oh, by the way, the reason I gave you the explanation why, because when I asked this question, somebody in class after that spring 19, after the test, somebody actually brought it up to me after the test, saying, "But Thomas, is there really such game?" I say, "Why? Well, that's of course hypothetical. I just make up stories. But if you ask me, is it possible? That's possible." And that person asked me, when? Which horse, which casino will be that stupid to do that? Okay, I said the casino that would try to bribe people. And then that person just stunned right away. Huh? What do you mean? Okay, casino is the place where money laundering have done a lot. Okay, and that's also the place where bribery may happen. Now, I'm not saying American casino like that. Okay, I'm saying that it can be done that way. It can be done that way. So I give you ideas how to be an evil, huh? Okay, come back here. So there are only 2 Fanta. The remaining are not. And when you select 2 tins, 2 cans from there, you need to select both Fanta and, of course, nothing else. That's 2 choose 2 times 7 choose 0 over 9 choose 2. That's 1 times 1 over 36. That's 1 over 36. Okay. Oh, you know what? I make a little mistake. About the payout. About the payout. There's one more possible outcomes that not explicitly say, but supposed to be written. The payout of 0. Okay. How do we know that we have that payout of 0, Thomas? Because of the following. If these are 10, 50, 100 are the only payout, then when you add the probability, supposed to be 1. You see what I mean? I mean, when you create the probability distribution, you're supposed to get the total to be 1, right? Okay, and if you are missing that 0, then it is not probability distribution. You see? Okay, so let's say our x and the probability. If only 10, 50, and 100, if only those 3, you see when I add the probability, that's not 36 over 36. That's only 10 out of 36. So where are the rest that make up to 1? Make it up to 1. There must be the event where you get nothing, right? You play the game and nothing happened, right? You don't get any one of those possible outcomes. That forces this that there is an outcome where there's a payout where you don't get anything back. Okay, now the probability will be 1 minus those numbers. By the way, don't make it decimal, because once you make it decimal, you will have too much rounding error. I did LCD here. I get 26 over 36. Okay. So I try to put it this way. Earlier, I didn't put that 0 purposely. Well, not because I just realized. Purposely because I want to show you that when you add the probability of all possible outcomes, in this case, all possible payout, if it is a probability distribution, they should add up to 1. Okay? But when we compute probability of 10, probability of 50, probability of 100, they don't add up to 1. So do you always win? No, you don't. We don't always win. There are times we don't win, but doesn't mean we lose. Okay, this is to cover the question if this game ever brought up to the court. Is that a game that you always win? Then I can legally correctly say no, I don't always win. Does it make sense? Unless the question is being framed, is it possible for you to lose? Then in this game, there's no chance for you to lose. But if the question by the court, by the judge, or by the prosecutor that is there a chance that you lose, that you don't win means you don't get that 10 or 50 or 100. Yes, there's a chance. Instead, it's high chance that you don't win anything. Notice that the question was framed about in a way that do you win or not winning? Not about winning or losing. No, it's win or not winning, right? In this case, that's true. Either you win 10, 50, 100, or you don't win. But there's no chance to lose. Now, all you need to do is play a game in which the player have no chance to lose. Now, to make it even not obvious that it is gambling. Now, recently, if you watch the video from my from fall 20, spring 20, then you will see I changed the situation that there's a chance these people lose. Okay, but make their loss very small. Let's say if they lose, they will lose $1. Right? Such that later on, when you compute the expected value, it is still positive, and basically, the player will win in long run. Okay, that is a newer way to bribe people to give transfer your wealth without paying the tax if the tax is pegged at certain level. Okay, it's just game, person to person game, and I play that game, I win. Okay, I feel so evil teaching you how to bribe and make it look legal. When I add this, I get 310 over 36. Now, how did you do that so fast, Thomas? When you multiply two fractions, you multiply the top with the top, bottom with the bottom. If one of them integer and the other one fraction, you just multiply this. The denominator stays the same. Okay, now the top, 50 times 3, 150. 100 times 1 is 100. 0 times whatever is 0. Okay, so the reason I don't want you to convert that to decimal, because once you make it into decimal, then you need to use calculator. And the decimal is not even accurate because we have rounding error, right? Okay, that's why I say, no, just leave it in fraction first. Now, your final answer later on, if you want to make it into decimal, go ahead. Okay, basically, if you do rounding, you round it at the last step. So the expected value here will be 310 over 36. Okay, which in 5 decimal places is 8.61111. Okay. Now, if I want to find the variance, then I go on further doing the second extension. X squared, this is 100. 50 squared is 25 with extra 2 zeros. 100 squared is 1 squared is 1. 2 zeros becomes 4 zeros. Multiply by the probability, this will be 600 over 36. This is 7,500 over 36. This is 10,000 over 36. I multiply the probability by x squared. Probability by x squared. Of course, the denominator stays 36, right? This is 0. When I add them, this will be 18,100 over 36. So the variance will be 18,100 over 36 minus 310 over 36 squared. That is 428 something. Now then the standard deviation therefore is the square root of that. We get 20 something. Okay, that's the end of our page 3. Let's go on. Page 4. The following Venn diagram describes the number of elements A, B, C. Now just use the notation, don't need to compute into decimal. But what if I do Thomas, then I don't mind, I won't even check that. But let's see first how many elements do we have. Okay, the number of elements here is 10 plus 9 plus 3 plus 14 plus 1 plus 2 plus 4 plus 7. So this is 10, 22, 36, 46, 50. Oh, there are 50 there. Okay, now if 3 items, 3 elements selected without replacement from the diagram, what is the probability that 2 of them from B? How many elements in B? That's 7 plus 4 plus 2 plus 1, that's 14. Now then the configuration here, you have 14 elements from B, which means 36 not B. The total is 50, right? Okay, now you select 3 elements, 2 of them from B, means 1 of them not from B. So the probability that the number of elements from B is 2 is 14 choose 2 times 36 choose 1 over 50 choose 3. And that's it. I don't need you to compute it to decimal. Which you can, I don't mind, but you don't need to. Part B, find the probability that the first 2 are from C, the last one are not. The last one is not from C. So how many C's, by the way? Number of elements in C is 14 plus 4 plus 2 plus 3. That's 23. Huh? Okay, so 23 from C, and the other 27 are not in C. Now you need to get the first two from, oh, the order is important. Huh. So I cannot just do 2 like that. Probability that C and then not C. Okay, now what is the probability? The first one is C, that's 23 over 50. What is the probability? The second one also not C, but it is without replacement. So after you take 1 from here, there will be only 22 left, right? 22 over total of 49. Now, when you take 1 from here, then there will be only 21 left. But then you need to take 1 from here. So that will be 27 over 48. Okay, and that's good enough. That's good enough. Okay, now, some of you may have this. Thomas, can I use permutation for that? Yes, definitely, because it happens to be done. You can do this with permutation. What you do is 23 permutes 2 times 27 permutes 1 over 50 permutes 3. That's also doable that way. Okay, that's also doable that way. So which one you would like us to do, Thomas? Either one is fine. I'm happy enough if you know one of them. But I share these both methods to you in case that two of you do it different techniques and you think that you get it wrong. Okay. No, that's simply because the technique is different doesn't mean it's wrong. How do we know it's correct? Well, just compute them. You will get the same number. Okay, you will get the same result. It's approximately 1/8. Okay. Now part C, find the probability that at least one of them is C. That's if the complement of none of them is C. So none of them is C means all 3 are not C. That is 1 minus 23, choose 0 times 27, choose 3 over 50, choose 3. Now, because none of them C, it is also possible to be done manually, like 1 by 1. That's 1 minus, what is the probability that the first one is not C? That's 27 over 50. The second one also not C, that's 26 over 49. The third one also not C, that's 25 over 48. So you can use either this one, and you don't need to compute it, right? Or you use that one. Okay, those reflects 2 totally different way of thinking, but still lead to the same result. Okay, by the way, some of my old tests don't ask this kind of question in the past. Well, it's an old test, so it's the past. Instead, beside asking you this, I may ask this one. What is the probability A knowing C? What is the probability B knowing not A? Like that. Okay, if we select one element, what is the probability of the conditional probability? What is the conditional probability? Okay. Now, notice that in your test 1, as far as I remember, you don't have conditional probability at all. So I may ask this in your test. Okay, I may ask this in your test. Just get prepared, though. Just get prepared. Just get prepared. I mean, I think if we go over my spring 17, you will see that type of question. I don't know. I don't remember precisely. Okay, let me finish this up. The last question, number 8, Poisson distribution. I remember that semester at West LA College, that semester Poisson distribution was enforced to be in department final. At West LA College, we have department final for Math 227. So the department was the one writing the test, okay, and the instructor just give the test for the final. Okay, at East LA College, however, until now, we never have a common final, department final for Math 227. So it's actually up to me at that time. Do I want to put it in there? Do I want to teach them or not? But the way I see it's like, hey, you know what? I don't want to do different speech, prepare different things for two same classes, right? So at East LA College at that time, I did not ask Poisson distribution in their tests. However, I asked exactly the same question in their homework. I give them homework. Of course, I explain it in class first, and then I give them homework regarding this. And I say, that's because next semester, fall 19, I will start asking question on Poisson distribution in my tests. So I try to phase that in also slowly. Okay, that's a little background. So if you happen to have access to my spring 19 Math 227 at East LA College, you will see that the tests I gave that semester to these two classes for test two are different. Okay, slightly different. And the difference only page 5, as I remember. Okay, now with you, you will have Poisson distribution. That's why I give you the one from West LA College. This test is the test 2 from West LA College. Okay, but still on the easier side. Okay, let X be the number of customer. This X is Poisson distributed with average 3 per minute. Now, part A, find the probability that at most 4 arrival in 2 minutes. Oh, not in 1 minute, in 2 minutes. So I need to adjust the mean, right? Okay, so X will now be Poisson distributed with the average 6 for 2 minutes. Yeah, multiply by 2, right? So this will be Poisson CDF 6, 4. 6 is the average for 2 minutes, and 4 is the number of success you want to achieve. That's 0.13385. Part B, find the probability that there is more than 10 in 5 minutes period. Oh, it's 5 minutes now. So the random variable, the number of customers, will now be 3 times 5 for a 5-minute period in average. Right? Those three, this 3 is from here. The 5 is from here. Okay, so if the time interval changes, the average will also change for the new time interval. Okay, and this is equals to 1 minus probability that at most 10 in 5 minutes. That is 1 minus Poisson CDF. The average now is 15 in 5 minutes period up to 10. That's 1 minus 0.11846. That's 0.88154. Find the probability that the time between consecutive arrivals is less than 2 minutes. Like from one customer to the next customer is less than 2 minutes. Which means if you have 2 minutes period, you have at least one arrival. Right? If you have 2 minutes period, you have at least one arrival. So this will be probability that X is at least 1 in 2 minute period. Okay, that is 1 minus probability that no arrival in 2 minutes. Don't forget that if it is 2 minutes, then the distribution will be Poisson with average 6 now. Because for 1 minute, the average is 3. So suppose that you are the only cashiers or you are the only storekeeper, right? You are the only staff working in that small store right now, and you need to go to restroom, and you know that I can do it in less than 2 minutes. But what is the probability you go to restroom and one customer suddenly appear during that time when you go to restroom? Okay, then that is the computation. Will you take the risk? Or will you close the store for 2 minutes? Right? I worked for a store also before. And it's a small store. It's a small convenience store. The size is approximately like 3 by 4 meters. And there were times I was alone and I need to go to restroom. So I asked myself, okay, what should I do? Should I just go and take a chance, or do I close it first? Okay. It's a small convenience stores. The average is actually less than 1 per minute, even per 2 minutes. In 2 minutes, there's a big chance that nobody there. So if I need to go to restroom doing number 1, should I just go, or you know what? I don't want to risk anything. I lock the door first, and then later on I open it. Right. Okay, now I compute that. That's Poisson PDF. The average is 6 in 2 minutes. The probability that nobody show up at all is, ooh, that's very, very small, Thomas. So if your average is 6 customers coming into that store in 2 minutes, and you need a 2-minute times out, the probability that somebody appear at that store and you were not there is 0.99752. The probability is very, very high. Okay, so either that person complain, hey, anybody here? Are you trying to do some business or not? Or that person says, hey, nobody here. Why don't I just leave without paying? Right? Okay. It may happen 2 ways. Of course, it could be there's a lot of people gracious enough to like, oh, you know what? Nobody here. Maybe that person just went to the restroom for a while. Let me wait. Right? Okay. But those kind of people get less and less common recently. Okay. Still more than half will wait, but it's less recently. We have more and more people just think that if they can take something from you for free, they have higher chance to do it right now compared to 10-20 years ago. Okay, I believe this is the end of our sample test, all tests that I go over. Okay, I will take my break and come back in 10-15 minutes. I will come back at 10:15. Right now it's 10:01. Okay, see you later. This is from fall 2017, Math 227 at East LA College, Test 2. Solution. Number one, according to Real Clear Politics poll conducted during January 3rd to 18, so approximately during the week and 2 more weeks after Mr. Trump inauguration. Oh, no. I'm sorry. This is like around 2 weeks before Mr. Trump inauguration. Okay. And then 50% actually approve Mr. Obama's work at the end of his presidency and disapprove 39%. And I wonder, some people just keep on thinking that, oh, Thomas, you asked this question because you want to show your support to Mr. Obama. Now, it doesn't imply that way. I am not saying I approve or I disapprove him. I'm not saying I support or I'm not supporting him. Okay. As a president, I have to support him. Okay. Whoever the president is, I will support that person's job. Okay. Maybe in personal way, I say that whoever the president, I always keep that person in prayer. Now, I hope that means something for you. Okay. Now, regardless who that person is from which party. Okay. Just please don't take it in a negative way or a positive way that oh, it's simply because you support that person or not. Nah, no, not in that way. Okay. But we still need to compute what percent of people can't really tell. Okay. This is 0.96, right? 0.96, so 4% undecided. Okay, so part A, of 70 people, what is the expected number of people approve? Then the mu will be 70 times 0.57. 70 times 0.57, that is 39.9. Now, don't round it to 40. No, just leave it like that. This is expectation, so it doesn't have to be an integer. Okay, in long run, on average, if you keep on randomly selecting 70 people, on average, 39.9 of them will say that they approve his work at that time. Okay, now then part B, of 50 people, find the standard deviation under people or do not disapprove. Notice that the question here is not find the standard deviation, the number of people who disapprove, no, or who approve, no. Not disapprove is the complement of disapprove. So what percentage of people not disapprove? Not disapprove will be the complement of 39%, right? That is 61%. Okay, pay attention. This is not disapprove is not the same to approve. Okay, not disapprove is 61%. Now, of those not disapprove, some of them approve, some of them undecided. Okay. Now, the reason I bring this up to you is because some journalists, especially in the last 5, even 10 years, have the habit of purposely only mention the statistic that fit their narrative. Okay, the support of President Obama at the end of his presidency is actually pretty good. It's 57%, right? But to improve his number, the journalist may purposely use the phrase not disapprove to have that 4% extra to approve. Okay, approve only 57, but if they decided to say not disapprove, then the percentage or the proportion will become 61%. Okay, now I cannot explain this kind of things to those who are not my student. That's one. Second, I cannot explain this to those who don't learn statistics on how people use statistics and, to make it worse, abuse statistics. So this person didn't do it wrong, but he purposely used the phrase not disapprove to increase the number. Okay. Now I'm telling you this not because I'm just trying to say that they are wrong. No. I'm saying that you still can do things right even if you have your own agenda. If you want to improve, if you are someone who want to improve Mr. Obama's image, then do it this way. And it's not wrong as long as you say it right. Okay. But on the other hand, if you are someone who happen to be on the other side of Mr. Obama's, and you can still read that and say, you know what, this person just play with numbers. Okay. Only those people who don't learn statistics in critical way will not realize how the numbers being played with different change of wording. Continue. So if P is 0.91, then the Q will be 0.39. They need to add up to 1, right? And then the variance, therefore, is N P Q. 50 times 0.61 times 0.39. That's 11.895. That's standard deviation. I'm sorry, that's variance. The standard deviation, therefore, is the square root of that number. That's 3.44891. Don't forget the notation. Okay, the notation for standard deviation, either sigma subscript x, or like I wrote there, or sigma x, or simply sigma if the context is clear. Okay, but do not use SD of x. No, that's not acceptable. That is not acceptable. We have enough professors and enough statisticians who reject that notation for standard deviation. Okay, including me. No, SD never stands for standard deviation. Okay. Part C, probability that of 16 people, more than half of them disapprove. Probability of disapproving is 39%. Right? Probability of disapproving is 39%. Okay, so probability that at least or more than half, more than 8 means up to 9 from 9, right? 0, 1 up to 8, start from 9 up to 16. The event that 1 is greater than 8, that's the complement of up to 8. That is 1 minus binom CDF, the number of trials, 16, probability of each success, which is disapproved, is 0.39 up to 8. That is 1 minus binom CDF 16.398. That's 0.87583, which is 0.12417. That's the probability of more than half disapprove. So if you randomly select 16 people, there's a 12.4 something probability that more than half of them disapprove Obama's work, even the population have 57% probability of supporting, of approving. Part D. What is the probability that none of those 16 are undecided? So of 16 people, the portion undecided is 0.04. So probability that none of them undecided. Oh, this one is easy. Binom PDF 16, 0.040. At 0.52040 probability that nobody is undecided. Part E. Of 60 people, find the usual interval for number of people disapprove. So n equals to 60. The disapprove is 39%. So the expectation will be 60 times 0.39. That is 23.4. And the variance is 60 times P times Q. That will be 60 times 0.39 times 0.61. I get 14 point something. So the standard deviation will be square root of that number. That is 3.77809. So for the interval, lower fence will be the mean minus twice standard deviation. The upper fence will be the mean plus twice standard deviation. Am I recording this? Yeah. I get the lower fence to be 15.84382. So it is quite unusual to have among these 50 people, 60 people, to have 15 or less disapprove. It's quite unusual. Okay. On the other hand, it's quite unusual to have more than 31, more than 30. So because this is 30.95618. So the usual interval that is 15.84382 to 31.95618. By the way, my question one here happens to be something I took from politics. Now, I have no intention to imply whatsoever support or not supporting whoever the president is. Please don't take it that way. Okay. Now, if you want to ask my political affiliation personally, I am more into independent. I'm more into independent. Okay, but If you ask me, do I support the president? My answer is always yes, whoever the president is. Okay. I put those people, important people, in prayer. Okay. Now, but so what is the reason you put this, Thomas? Just to apply your stats. Just to apply your stats. Okay. It is actually a big challenge, though. It is a big challenge to apply your statistic. Stick with the science, regardless what is the outcome. Can you use statistic, pure statistic, without inserting or without exposing your own opinion on what you're supposed to do? Now, that's not easy. That is not easy. Okay. Now, so it does take some independence to be able to see things clearer. Like, can you take away your willingness to show support of President Obama at that time? Okay. Other than just being a citizen. As a citizen, I support him. I want the best for him, just like I support Mr. Trump, and just like I support Mr. Biden. And I saw some posting on my Facebook wall about Mr. Biden happened to slip a little bit on his way up to Air Force One. And I saw people create memes on that. And I told them, no, this is not, I don't approve this. That's first of all, I don't approve you making jokes of the president this way. And no, that's not who we are. I mean, if you don't like him, criticize his decision and tell why. But these kind of things that, I mean, you slip on your way somewhere, it happens to everyone, including you and me. Okay, so that's, don't make that kind of cheap shot. Okay, there's no need. Okay, I don't like that. I told those people. Some of them my friends, though, very close friends. And I need to remind them, hey, you know what? He's not a perfect person. Okay, so I do expect you to say that he didn't do this right or that right, and that's fine. But for him to just like miss a step on his way to Air Force One, and you make it everywhere on Facebook, why don't you do that to other president? I mean, president from another country. Okay, it's not that those things never happen. You want to talk about Prince Harry and Meghan Markle? Right? We have more things to say there, actually, right? Okay. It's like, why do you want to do that to your own president, dude? Okay, let's come back here. Let's talk about lottery, my bigger interest. Yeah, I'm about to go to Vegas, so yeah, excited to gamble after more than 1 year, actually more than 2 years. Actually, I don't gamble, but this time I tell myself I have to gamble. I get the free room, and they told me I have to gamble at least 4 hours for 4 hours for 4 days stay. So in other words, 4 hours, I have to play 4 hours in that 4 days stay, not 4 hours every day. No, during that 4 days, I have to play at least 4 hours. Just make those Venetian palazzo happy. So I will do that. Okay, mega lot lottery. So I create a new lottery. This is hypothetical. Draws 4 regular numbers out of 50 numbers. So 50 numbers, 4 of them correct one. Of course, 46 is incorrect. And 2 mega numbers out of 15. So 2 of them correct, 13 of them wrong. Okay, part A, find the probability to correctly select none of these numbers correctly. So none of them correct. So if this is none of them correct, means the 4 that you select must be wrong. None of them correct means the 2 mega numbers you select must be wrong. That will be 4, choose 0 times 46, choose 4 over 50, choose 4 times 2, choose 0 times 13, choose 2 over 15, choose 2. You will see the probability is actually quite high. Okay, that you don't get anything right, all of them wrong when you play lottery. That's why I don't play. Okay, that's a better option. Only play such lottery if you believe doing so make your satisfaction, make you happy, and the happiness is something you are willing to spend that money on. Let's say to purchase one such ticket, lottery ticket costs you $2, and just ask yourself, will I be happy enough and willing to pay $2 simply because I play that regardless I win or not? Okay, simply because you play that, give yourself a chance. Regardless I get anything or nothing, I will be okay. Then do so. Okay, but if you are playing this lottery for the purpose of winning only, then don't do that. Okay. Okay. Now, if you ask me, do you do this, Thomas? Do you buy lottery? Sometimes, if I see that the jackpot is more than 300 million or 400 million, then I take it. Okay, I buy it. Maybe buy 2 or 3 tickets like that. Okay, and I know it's just like to have fun. Okay, but don't you think that's a waste of money? Well, to have fun always waste of money. Okay, the difference is I happen to have that extra money to do so. Okay, but Thomas, why don't you just give your money to your students? Well, I give money to my students. Okay, but even if I don't, you have no right to tell me what to do with my own money, right? Okay, if you do, say that to IRS first, dude. No. It's more about this. Regardless, I help some of my. I do help some of my students. I want you to realize that. Okay, I do help some of my students. Okay, I have seen. I can even give you a name if necessary, but no need. Okay, but I support one student at UC Irvine. I'm sorry, UC Riverside. I support one student at UC Riverside, and this June he's supposed to graduate already, electrical engineering. And I'm proud to tell you that. Okay, and to be honest with you, I once shared that situation to another faculty, and this is personal story. Yeah, I shared this to faculty, and that faculty say, you know what? This is what happened. Let me share this with you. These students happen to be somebody who impressed me very, very well. I mean, I love these students so much, and he studied very, very hard. I can tell, right? And doing very well with his study. He got 4.0 at West LA College. Okay, he took my pre-calculus and then took my calculus 3 also, get A's. Okay, he struggled, but get A's. Okay, at the end of his calc 3, he's actually get very, very strong A though. But when he took pre-calculus with me, it was it's quite weak. So imagine this person who took pre-calculus from me at West LA College, that's Math 260. And then took Calc 1 from somebody else, Calc 2 from somebody else, and then Calc 3 decided to take it with me again. Okay, in pre-calculus, his first test was a C. He said that's the lowest math test result he ever get in his life. So he studied so hard, and in the end, he still got an A in my pre-calculus, barely A. Then he took calculus 1, calculus 2. He was laughing at the teachers. Thomas, they're too easy. They just try to make students happy. That's why for my calc 3, I decided to take it with you again, knowing that I'm risking my 4.0 GPA. But at that time, he was actually a lot more prepared as a student. So he got a strong A from me and then finished his study at West LA College, transferred to UC Riverside. Now, this student is a single student in a sense that he has no family here. He has no family whatsoever. He was alone with some friends that he made at West LA College, and he's from Africa. So he's Black. When he transferred to UC Riverside, he was working as a security person at some, what do you call that? some kind of like club, not nightclub, but a place that people go and drink like that. Okay, so it's a job that he himself doesn't like. But he say, but Thomas, that's the only job as a security like that. I don't need to walk around. I just need to stand outside the building. And I can actually study during those times. And that's why I kept that job. But once he moved to UC Riverside, he cannot keep that job because his job was in downtown. And last year, that happens to be his second year. He said, Thomas, the financial aid I get is not enough. He shared that with me. And it's quite, things were difficult. Now, mind you that he didn't actually reach out to me to ask me that question. I actually reached out to him and asked him, hey, how are you doing now? Okay, especially in this pandemic. And then he starts sharing, Thomas, you happened to ask that question. And so I just shared it with you. And he was surprised when I say, how much do you think you need to survive for the next 1 month without being hungry? And he say, oh, well, Thomas, I never really counted. I said, well, $1,000 enough? I said, what do you mean by that? I said, well, I'm willing to send you $1,000. I let you borrow it. I don't want to give it to you. I want you to borrow it because I know one day you will be successful. You can pay this money back. Okay, but Thomas, when do you want me to pay it back? I say, I'll give you 10 years. Even 20 years, I don't mind. But I know I have faith in you that one day you will be rich enough to pay this back. And I prefer you to pay it forward to people who at that time not able financially. Okay, just I want you to remember that one day somebody help you and one day you can be that kind of person also. He was so happy. He was so happy. And you see that it's just for $1,000. It's not big for me, but it's very big for him. In fact, he shared with me later on that, Thomas, I used that $1,000 and survived for 2 months instead of only 1 month. I appreciate him doing that. Okay. And when I shared this with a colleague at West LA College, hey, we have these students, and this colleague happened to know him also. And I say, would you mind to share some of your fortune with him because he's actually at risk of being hungry. And I would really like to have this kind of students being helped. Government's hands is not long enough for everybody. Okay, so can I ask you? And to my surprise and disappointment, you know what that guy say? My colleague say, why don't we open GoFundMe? And ask other people to donate. I say, no, I'm not asking other people. I'm asking you. Will you put your own money? It's like, instead of asking other people to put their money, how about you put your own money first? Okay. And he say, oh, no, Thomas, I have this, I have that. You know what? Let me tell you. Everybody have their own need. When it comes to money, it's never enough. Okay. Never enough for me, never enough for my family. But will that touch your heart? And I hope one day you will be rich enough to have that kind of heart. If I have any prayer for my students, only one, I pray for that one. That one day you will be willing to share your rich, your fortune, your luck, your grace to other people and make yourself a channel of blessing. Coming back here. Find the probability of correctly select 3 regular numbers only. So regular numbers, only 3 correct. So one of the regular is wrong. And because I say only 3 regular numbers, it means the mega number also wrong. Okay, now then, what's the notation? That will be 4, choose 3 times 46, choose 1, times 2, choose 0, times 13, choose 2, over 50, choose 4, 15, choose 2. That's the notation. That's the end of our page 1. Go to page 2. The following lists the probability distribution of X, the number of children a randomly selected college student has. So if you randomly select a college students, how many children that student has. Okay, we know that some of our friends, including maybe you, already have children, and it becomes heavier, more difficult for them actually to focus on their study. Okay, now my Friday class especially have that in mind. My Friday class especially have that in mind. In the past, they actually asked me to teach on Saturday instead. Okay, but Saturday classes, because they try to save money, so they close a lot of Saturday class, so I end up teaching Friday class. But in the past, when they asked me, I prefer to teach Saturday class. Why? Saturday class very likely are people, especially mothers, who with children. Now they cannot come to school on weekdays because they have children at home. Their husband need to go to work. Somebody needs to take care of the small children. Okay, so they can only do so when their husband already at home on weekend, during the weekend, such that they can come to school to study. Okay, now admittedly, we have more women in that situation compared to men, right? And I keep on asking the college to just keep those Saturday class. And if nobody likes to teach that, I will, why? Because these people, these ladies, usually when they come back to school, now this can be you too, okay? When they come back to school, they already have sense of purpose instead of just those high school students barely graduate and they come to East LA College because their parents or their friends come to East LA College. Yes, they come to East LA College because what people do, but it's not a sense of purpose on their own. Saturday class, I have more students who are dedicated. They don't have time, but they make time. Okay, that's why, to be honest with you, sometimes I get a bit pissed off. I grunge a little bit in my heart when a high school graduate of my students says, "Oh, I don't have time. I don't have to do this. I have to do that." Dude, how how busy can you be if you have no children? It's like once you have a kid, that's very busy. You can ask my wife. 2 children already make her busier than a lot busier than me multiplied by 2. You multiply my time by 2, it's still not as busy as she does. Okay, she wakes up at 5 o'clock in the morning, and last night she slept at like 1 or 2 o'clock. Okay, I wake up after her. I sleep before her. Now, tell me if I won't appreciate what she does for me, right? And tell me, how can I not appreciate those mother out there, right? So the expected value here is 0.65. Okay, so on average, the number of children our college students has is 0.65. How to use this number, Thomas, in future? We use it this way. Suppose we have 1,000 students, right? Okay, and then we say, oh, let's invite their children. And let's say all of them happen to be free and happy to bring their children to us. How many children do you expect to show up to our party? And we'll multiply that by 1,000. Multiply that 1,000 students by 0.85 average. Then you expect to have 650 children actually coming to our party. That's how we use that. Okay, speaking about estimating. But Thomas, some people have this, some people have that. Yeah, okay, more or less, then you more or less that you have that number 650, maybe more, maybe less, but it won't be way too far from there. Well, if it is deviating, how much deviating that will be? That's why we compute the standard deviation. Okay. This is 0, this is 0.2, this is 0.6, this is 0.45, so this is 1.25. The variance, therefore, is 1.25 minus 0.65 squared. 0.8275. That's the variance. The standard deviation, therefore, is the square root of that. That is 0.90967. Okay, that's for number 3. Let's go on to number 4. Number 4, a box contains 12 identical marbles except in colors. In the past, I use balls. Sometimes I use markers. And you see in the other question, I use tins like can of sodas, right? But it can be anything though. It can be anything. You can say a class contains 12 students and 5 of them, let's say, from California, the other 4 American, but from other states, and the other 3 are international students, like that, okay, and so on and so forth, right? Okay. Now, part A, 4 marbles are selected at random, one at a time, with replacement. With replacement. Find the probability of selecting any red marbles. It is with replacement, you do it 4 times. So it becomes binomial, right? The n equals to 4. Probability of getting a red, if you do it 1 time, that will be 3/12, which is 1/4. Okay, now what is the probability that you get at least 1 red? Any red marbles, at least 1. 1 minus probability of no red. Now you can do it 1 by 1 also, like probability of getting no red is 9/12. And you do it 4 times, right? But I think let me just do it with binomial here. Now for my previous test that I went over, I show you both methods, right? Right now I just show you one way and mention verbally that you can use another way also. Okay, so that's 1 by minus binom PDF 4, comma 0.25, comma 0. That's 1 minus 0.31641, which is 0.68359. That's the probability of at least 1 red. Part B, 4 marbles again, but this time without replacement. Find the probability of getting 2 yellow first and then 2 red. Oh, let's see the configuration. 5 green, 4 yellow, 3 red. The probability of getting yellow and then red is 4 out of 12 times 3 out of 11 times 3 red out of 10 left over times 9, 2/9. I can cancel the 9 here. Let me use red. You can just use your calculator though, but I have a tendency that if I can simplify first, I do. And these 2 make it 6 here. Okay, this 4 make it 3. And that's 2. That's 1, 5. So 1 out of 55 times 3, 1/165. Just use your calculator. So at least I cancel that. So I get 8/12 times 11 times 10. What's that by calculator? That's 0.00606. Oh, very, very small probability, huh? It's like this. It's like this. It's like this. It is not that somebody already get 2 yellow first and then 2 red, and then I say, oh, it's the probability small. Okay, it's more about like this. Before you do the trial, I tell you, you need to get 2 yellow first and then 2 red. Can you do it now? The probability that you do it one time, you select 4 marbles at random 1 by 1 without replacement, you do it one time and you get what I tell you to get, and that's right away, the chance is 0.00606. Okay, it's not that after fact then we say that the probability is small. The context here is like, if I ask you to get yellow, yellow, and then red, can you get it right away? And the probability that you get it right away is that small. Okay, now part C, 4 marbles selected without replacement. Okay, what is the probability of getting 2 yellow and then 2 green regardless the order? Oh, okay, so we have 5 green, 4 yellow, 3 red, and you need to select 2 from the green and 2 from the yellow, therefore nothing from red because you select only 4, right? Okay, so probability of 2 yellow and 2 green, no order implied, will be 5 choose 2 times 4 choose 2 over 12 choose 4. Yeah, to be more precise, 5 choose 2, 4 choose 2, 3 choose 0 over 12 choose 4. But you will see if you don't type this in, if you don't write that, that's okay. Because 3 choose 0 is only 1, is 1. Okay, so if you see somebody didn't write that 3 choose 0 and I mark it okay, that's because 3 choose 0 is simply 1. Okay, now 5 choose 2 is 10, 4 choose 2 is 6, 3 choose 1, 0 over 12 choose 4 is hard. 495. So 60 divided by 495 is 0.12121. That's for part C. Part D. Create a probability distribution of the number of red marbles selected for a procedure of selecting 4 marbles without replacement. Now I want to get the red one. So let's R be the number of red marbles selected. What are the possible outcomes for this random variable? You may get no red, 1 red, 2 red, 3 red at most. Cannot be 4, even though you select 4 marbles, because you only have 3 red. Okay, so what is the probability that the number of reds selected is 0? Now, consider this box. There are 3 red, which means 9 of them not red. Okay, the probability that no red means all 4 are not red. 3 choose 0 times 9 choose 4 over 12 choose 4. Okay, then we compute the probability. Let me just leave it like that for now. Okay, let's compute what happened if we have 1 red. To have 1 red means 3 of them not red. Probability of 1 red will be 3 choose 1 times 9 choose 3 over 12 choose 4. Okay, I will compute that later on. But let me just leave it like that for now. Probability to have 2 red will be, this is 2, then this is 2, then 3 choose 2 times 9 choose 2 over 12 choose 4. Probability to get 3 reds is, if 3 of them red means 1 of them not red. That 3 choose 3 times 9 choose 1 over 12 choose 4. Now let's compute. 3 choose 0 is 1. 9 choose 4 is 126. 12 choose 4 is 495. I think we computed that earlier downstairs. Yeah, 495, that's right. So this is 126 over 495. This is 3 times 120 over 495. Is it that high? Hold on, 9 choose 3. I don't think it's 120. Maybe, but maybe not. 84, not 120. 84, my bad. So that's 252 over 495. 3 choose 2 is 3, 9 choose 2 is 36 over 495. That is 108 over 495. And this one here, three choose 3 is 1, 9 choose 1 is 9 over 495. That's 9 over 495. Now then, once you compute the probability for each, then you put them in the table. Probability that x is 0, 1, 2, 3. Corresponding probability, that's 126 over 495. 252 over 495. 108 over 495. And then 9 over 495. And make sure when you add them, they add up to 1. You need to add them. Do not just assume they add up to 1. You need to actually add them. Okay, because if you assume they add up to 1 and turns out to be not, it means you are missing something very big, or you make miscomputation. I mean, it's a terrible miscomputation. It must be like that. Okay, remember earlier when I wrote this is 3 times 120? I would have 360 here. I would not detect that. I would not detect that if I didn't actually add this number. So adding those numbers without assuming it must be add up to 1 is a way for us to check our work. Okay? They need to, when I say they need to add up to 1, is a way for us to confirm that we did it right. Okay, at least from the add up to 1. Okay, it is possible that your technique are all wrong though, but they still add up to 1. Number 5. I think this question is the same to what we did earlier. Let me see, let me check. Spring 19, number 5. Probability of A is 0.5, B is 0.3. A 0.5, B 0.3. Oh, this is probability of A given B, and this one is probability of B given A. So it's very small difference, but it will lead to a very big difference. Okay, let's see. So probability of B given A. So it means I have to work it out. I try to be lazy, honestly. My mind is already on spring break, not only yours. Okay, that's the formula. So probability of B given A equals to probability of the intersection over probability of A is Write down the formula first, then you plug in numbers. So probability of D intersection will be 0.4 times 0.5. That is 0.2. How about probability of B given A given B? That's probability of intersection over probability of B. That is 0.2 over 0.3. That's 2/3, 0.66667. Round to 5 decimal places. How about probability of the union A and B, A or B? That's probability of A plus probability of B minus the probability of D intersection. That is 0.5 plus 0.3 minus 0.2, that's 0.6. How about probability of not A but B? That's probability of B, but we cut out the 1, including A's. That's 0.1. Now, how about probability of B given not A? That's probability not A but only in B over probability of not A. Probability of not A given B is 0.1 over 1 minus 0.5. That's 0.1 over 0.5. That is 0.2. That's for number 5. Number 6. A game of fortune teens. See how creative is your teacher in creating names? Okay, so fortune teens draws 4 cans of soda without replacement with 5 identical identical cans except in brand. And that box has 6 Sprite, 5 Coke, 4 Fanta. Okay, the player wins $200 if all are Sprite, all 4, not 3. Okay, and Coke $400, all Fanta $800. Okay, let's see. Let X be the payout. Let X be the payout. Now this payout X can be $200 or $400 or $800. Now, of course, don't forget the case where you don't win anything. Now compute the probability. Probability that the payout is $200 is when you get all Sprite. Okay. By the way, before I go too far, I want you to realize that what we do here is being used in computing not only blackjack, okay, but especially when you play poker. When you play pokers, the computation we do actually very, very close to what we have here. Like for example, what is the probability you get royal flush? Right? What is the probability you get royal flush? What is the probability you have a pocket? What is the probability you get 2 pockets, 2 pairs? What is the probability that you have flush, but not royal? And so on and so forth. Okay, it's all combinations. It's all combinations. Now, sprite means all sprite. You select 4 cans, you have 6 sprite. So to have 4 sprite, it will be 6 choose 4 times the other 9 choose nothing over 15 choose 4. Okay, you create this box. 6 sprite, 9 not sprite. Okay, and you need 4 from here, and therefore nothing from here. Okay, I will leave it there, but later on I will not do that anymore. 6 choose 4 is 3 times 5, 15. 9 choose 0 is 1. 15 choose 4, I don't know. $1,365. So this is 15 over 1365. Probability that the payout is $400 if probability that all Coke. That is, you have 5 Coke, you choose 4 of them. The remaining 10 not Coke, you choose nothing. That will be 5 times 1 over 1365. Probability that you get $800 is when you have all Fanta. And that is when 4 Fanta, 4 of them selected, and nothing from those 11 not Fanta selected. That will be 1 times 1 over 1365, which is 1 over 1365. Now, how about the probability of payout 0? Notice that the probability to win something don't add up to 1. Therefore, there must be an event where they add up to 1, right? And it must be because you don't win anything. That is 1 minus 15 plus 5 plus 1 over 1365. That's 1 minus 21 over 1365. That's 1344 over 1365. Now then, don't make it into decimal. You make your work a lot harder by doing so. Okay, so I will create the probability distribution and extend it. As I remember, they asked that question, right? They asked the question, construct the probability distribution of the payout and extend to find the expectation and standard deviation of the payout. Okay, so I need to create a table. X, oops, sorry. That's for X. And then the probability. And then for PX. And for X squared. And then PX squared. Okay. The payout are 200, 400, 800. 200, 400, 800, and 0. I give myself more space. 15 over 1365. 5 over 1365. 1 over 1365. 1344 over 1365. When I add them, we expect that to be 1. Now let's do the computation. 200 times 15, that's 3,000. 400 times 5, that's 2,000. 800 times 1, that's 800. This is 0. So when I add this, I get 5,800 over 1365. So the expected value of the payout will be 5,800 over 1365. On average, when you play this game, you will get $4.24908. In the long run, if you play this game, on average, you will make $4.25 approximately per game. So how much will you have at hand if you play this game 1,000 times? When you play this game 1,000 times, then we expect you to have approximately $4,249. Approximately. Okay, maybe more, maybe less though. To know how much more to be reasonable, how much less to be reasonable, then that's when we use standard deviation. Okay. Okay, now the next extension, 200 square is 40,000. 400 square is 160,000. 800 square is 640,000. This is 0. Now then multiply by 15. This will be 60 with 4 zeros. Times 5, this will be 80 with 4 zeros. So 640. Which when I add 600,000 plus 800,000 plus 640,000, I get 2,040,000 over 1,365. Therefore, my variance will be 2,040,000 over 1,365 minus 4.24908 squared. I get 1,476.45078. So the standard deviation of the payout will be the square root of that. That is 38.42461. Now, just for fun, suppose then I change the question, just continue from there, okay? I will not ask you this kind of question in your test, not even in your final, but how to use this number. Suppose Thomas plays that game 100 times. So what is the expected number of, what is the expected winning he has? The expected winning will be 100 times 4.24908. So you expect to have, he should have expect to have win 400, around $425. But you know, he may win a lot more than that. He may possibly win nothing. Okay, so let's compute the standard deviation. The standard deviation of his winning will be 10 times of that original standard deviation also. So that's not 10 times, 100 times, I'm sorry. 100 times 38.042460. I'm sorry, 61. Okay, so there will be 3,842.461. Now, multiply that by 2. Okay, so what is the usual interval of his winning after he plays 100 times? Then the upper fence will be, the what's that, $424.9 plus 2 times $3,842 something. Okay, more than that number, which is approximately what, 7,000, around $8,000. Yeah, more than $8,000. That's quite unusual. Okay, that's quite unusual for him, for Thomas, to have won more than $8,000 something after playing it 100 times. On the other hand, the lower bound, which is 424 something minus 2 times 3,800 something, that's a negative number, right? That's a negative number. It means it is usual if Thomas won nothing. Thomas played 1,000 times and he won nothing. Is it usual? That's usual. That's common. Okay, that's common. Now, of course, the computation is not precisely like this, but that's a very good way to do that already. Okay, that's a good way to do that already. I try to explain that it makes sense. If you play 100 times, you make nothing. It's still useful. Okay. Now let's go back to the topic. I just show you how to use these numbers in future. Okay, let's go to number 7. Oh, we saw this question before. Similar one. Okay, suppose 3 elements are randomly selected without replacement. Okay. I need to compute how many elements in there first though. That's 13 plus 12 plus 5 plus 18 plus 4 plus 2 plus 7 plus 10. 25, 30, 48, 52, 54, 61, 71. Am I right? 25. This is 23. That's 23. Yeah, that's 71. Part A, find the probability that all of them from A. How many A's There will be 12 plus 4 plus 2 plus 5. That will be 18 plus 3. That's 23. Okay, so what is the probability? All of them from A. All from A. You can do this. You see that you have 23 of them A's. It means the remaining 48 are not A's, right? If all 3 from A's, that will be 23 choose 3 times 48 choose 0 over 71 choose 3. Now, you can also do it one by one in this case because all of them A anyway, right? Okay, you can do it one by one. The second way, 23 over 71 times 22 over 70 times 21 over 69. You will get exactly the same result if you do it that way. Okay. Part B, find the probability that 2 of them from B. So how many B's, by the way? 4 plus 2 plus 7 plus 10. Oh, 23 also. Surprise. Is it right? Yeah, it's 23 also. So what is the probability? 2 of them from B. Then there will be 23 choose 2 times and 48 choose 1. Okay, the breakdown is 23 from B, 48 not B. You need to select 3, right? But if 2 of them from B means the other one not B. Okay. Now part C, find the probability the first 2 are from C, the last one not from C. Oh, this one I need to do it one by one. How many C's? That's 5 plus 2 plus 18 plus 7. 25, 32. So the probability that the first 2, so C and then not C. 32 from C, right? So 32 over 71 times 31 over 70 times, oh, if they are 32 in C, then how many not C? 39. They add up to 71. So that's 39 over 69. You can also do it using permutation. That is 32 permutes 2 times 39 permutes 1 over 71 permutes 3. That's also okay. You can do it that way too. Part D. Find the probability at least one of them from C. So probability C is at least 1, but that's 1 minus probability no C. 1 minus, there are 32 C, means 39 not C. Nothing from here means 3 from here. 32 choose 0 times 39 choose 3 over 71 choose 3. That's the probability. Yeah, I don't compute that because just use notation. Don't need to compute to decimal, right? So that's why I just leave it in that notation. Your notation tells me the way you think more than just if you give me numbers. Okay, because your numbers, there's a chance that your numbers actually rounded, and I don't even know how you get those numbers. Okay, now part E, the last question. Part E, find the probability that all of them from A or B or C, basically inside. So let's see how many elements in A or B or C. But we know there are 13 outside, right? 13 outside. 13 outside the union. Okay, you need to select 3 from anywhere here. That's what I meant. Okay, so the number of element in either one of those is 71 minus, is it 13? Yeah, minus 13. That's 58. Okay, so probability that all from A or B or C will be 58, choose 3 times 13, choose nothing over 71, choose 3. That's it. You can also do it one by one. That is 58 over 71 times 57 over 70 times 56 over 69. And all of them from anywhere in ABC. Okay, I think that's the last question for this test. Okay, I start from 10:15 earlier and I finish at 11:32. So, and with some story time. So this test is doable in 1 hour, 15 minutes. Okay. Now, I'm not saying that your next 2 weeks later, which is your test 2, when you come back, I'm not saying that 2 weeks later, you should do it in 1 hour, 15 minutes. No, no, not at all. I'm just saying that if you know your stuff, it is doable in 1 hour, 15 minutes. Okay. So don't get too worry about the time. If you already well prepared, you should be fine. Okay, you should be fine. Okay, this is the discussion which is not required for you to watch on your spring break. Okay, again, you are not required to sign in. I will not use that against you if you don't. And this is only for you to study during the spring break. Okay. Now, if you have any question during the spring break, you would like to ask, send me an email. I will try to reply you by email. But if I cannot, if I think I cannot make you understand easily in writing, then I will make appointment with you to go to Zoom. Okay, but I don't promise you to go to Zoom. Okay, yeah, I will try, but I stay at home anyway, so I will be back from Vegas on Monday, right? So I think I will just stay home after that during the spring break. But there's a chance that suddenly my friend or my wife wants to go out to other place for some other days. Okay, then see you in 2 weeks. Hey, make sure you study. Okay, and please give me those more than 100 again. Okay, 3 students did that before, and I hope I have even more in these 2 weeks. Okay, see you then. Bye-bye.